Hey pre-AP kiddos, this is our lesson 5-2, which is factor and expand expressions. This is one of our course 2 lessons, and so we're gonna put it in our math journal just like all of the rest of them. So set up your Cornell notes. We are gonna do a couple of examples on the next page also, so if this doesn't all fit onto one page, no big deal. Our learning target is to apply the properties of distribution, so when we did the distributive property, to factor and expand linear expressions. So all of this is already written out. I'm kind of just going to talk you through it because it was not really examples, more just walking through the whole thing. So our first thing, our little review here for how to distribute. Remember that we would always kind of circle that sign in between and then draw our arrow because whatever is outside gets distributed and multiplied by each of the terms inside of the parentheses. So for instance, A parentheses B plus C is going to be rewritten as AB plus AC, so A times B plus A times C. This is called expanded form. So when we expand it out and multiply that number on the outside by everything, that would be our expanded form. So an example down here of our equivalent expressions is we start out by, our first step is to distribute. So this is what you guys have already been doing. It's not going to be anything new. For instance, if we had this expression over here, which says 3, and then in parentheses, y minus 6 plus 4 on the end, we are going to distribute the 3 to only everything in the parentheses. So you are ignoring that 4 on the side for right now. So once I distribute 3 and y is going to become 3y, we write our minus at the bottom, and then 6 times 3 is 18. Now, we can't forget about that 4 over on the side. It's just not a part of our multiplying, our distributing, because it's on its own. So we write that down there also. Now, the ones where we distributed last week didn't have any like terms. We said in class, okay, this 3y and this minus 18, I can't combine those because the 18 doesn't have a y on it, so they're not like terms. But now our expressions, we've kind of added some numbers so that we now have to ask ourselves, how can I simplify this and combine like terms? So in this one that we just did, we now have 3y minus 18 plus 4. Well, the plus 4 and the minus 18, neither of them has a variable on it. So those are like terms. We can combine them. So I'm going to say, okay, negative 18 plus 4 is going to get me minus 14. So now instead of 3y minus 18 plus 4, we combined our like terms and we have now have minus 14. Another example down here is we have 2 and then in parentheses 2a minus 1 plus 3a. So this is the whole thing. Now, once we expand and distribute, this 2 times 2a becomes 4a. Then we have 2 times our 1, so minus 2. And then we have the 3a that was at the end by itself. I'm just going to rewrite that over here because that was not a part of my expanding. It was just on its own. So now we have 4a minus 2 plus 3a. And we see the a's are obviously our like terms, what we can combine. They both are positives. So 4 and 3 is going to get us 7a. And then we can't forget about that that minus 2 in the middle. So we have 7a minus 2. So you distribute, then once you're done distributing, you look at your like terms and see if there's anything that you can combine from there. Now, the other side of that was kind of our expanding side. This is how we factor. So factor means that we're going to factor out the like terms using GCF. Now, if you don't remember what GCF, remember that was our greatest common, sorry, my handwriting on these is terrible, greatest common factor. So, you'll get a little refresher if you forgot about it. Our steps, first step is to find the greatest common factor, the GCF. So if we were given this expression, 12x minus 18, we are looking for the biggest number that goes into 12 and also goes into 18. So for instance, over here we can see like 3 would go into both of those, 4 wouldn't, 5, 6 would go in, and then nothing else would go in besides, oh, I guess 2 also. 2, 3, and 6. We want the biggest one. So the greatest common factor or number that goes into both of those is 6. So what I can do for my second step now, since I see the biggest number that goes into both of those, I can divide that number out. So right down here what they did is they rewrote it and they said, okay, we're going to take 12x divided by that 6, and we're going to take 18 divided by that 6. Now when I rewrite it, 12x divided by 6 gets us 2x, and then minus, we just brought that down, 18 divided by 6 gets us 3. So they are factoring out that greatest common factor. And then at the end, we're going to rewrite it with the greatest common factor out. So basically, it's working backwards, and we want the end product to look like something that needs to be distributed. So here's what it looks like now. And you'll see that 6 that we divided by, we just take that and we put that on the side. And then this answer that you got once you divided that out, that's what goes inside parentheses. So it's kind of funny, you're learning how to go forwards to make an equivalent expression and how to go backwards. So we're really back to the beginning where we first learned how to distribute. So this expression is the same thing, is equivalent to that expression. They are both the same. If you plugged in a number for x, you would get the same answer for both of them. I'm going to do a couple of examples on the next page. It won't take long, I promise. If it can fit on this page, go ahead and fit it. If not, go on to the next page. Okay, a couple more examples here. Let's do 5a plus 3a. So in this one, I picked this because it looks different than the last one. You'll notice, okay, if you ask yourself, I can't take a number out of, there's no common factor between the number 5 and 3. But what you're not seeing is that they both have an a in them. So since the a is what they have in common, I can take the a out. So I'm going to divide this by a, divide this by a, which really means you're just taking it out. And so now you have 5 plus 3, and remember the steps. It said to write the greatest common factor, or that number or variable that you took out gets written at the front of it. So you're figuring out what they have in common, divide by that, take it out, and put it outside of the parentheses. So another example over here might be if we had 2a minus 10. They don't have a common variable, but I see that they're both even numbers. So if they're both even numbers, I know I can divide them both by 2. So I'm going to divide by 2, divide by 2. Now when I rewrite this, 2a divided by 2, that's 2 divided by 2 is 1. So it would be 1a, or you could just write it as a. So that one's going to be a. Then we bring down our minus sign. 10 divided by 2 is 5. So we have a minus 5 in parentheses. And then what was it that we had in common up here? The 2. So I write the 2 outside. So your final answer would be 2 and then a minus 5. Let's do one more. The last one, 6x plus 3y. So this one has 2 different variables. That's okay. I just know that I can't take out the variable because that's not something in common. Instead, I see, okay, 3 and 6 are both divisible by 3. Their greatest common factor is 3. So I'm going to take that out. 6x divided by 3, well, 6 divided by 3 is 2, and I leave the x there because I haven't gotten rid of that. I bring down the plus sign. 3 divided by 3 is 1y, but remember, 1y, I can just write y. And then I write my 3 that was what I took out of both of them at the beginning. So working forward and backward, you guys are all set. We'll do more examples in class. I really appreciate you doing this. You are helping yourself out so much. Have a wonderful rest of your night.